Good afternoon, and welcome to day 2 of this 2-day NASSCO webinar series entitled Manhole Rehab is a Team Sport. Regarding continuing education credit, it's important to attend both sessions to receive 2 PDHs or 0.2 CEU credits. Welcome back for those who joined us yesterday. We are blessed to have 800 registrations for this live learning event. So a live Q&A session at the end is rather impractical. Later this afternoon, you'll receive a survey with options to submit questions regarding the webinar content. Don't be shy, challenge us, but grant us a couple weeks to respond in writing with a resourceful FAQ document. And yes, this webinar is being recorded and will be available on NASSCO.org for future viewing. My name is Don Rigby, and I head up marketing and education at Madewell Products Corp in Alpharetta, Georgia. More important, I was chairman of the NASSCO Manhole Rehab Committee for a couple of years. What you're going to see today was initially a 4-hour short course delivered live at UCT Nashville Conference in 2021. Yes, this was primetime COVID season. Only 60 people were able to attend. Each of the 5 subject matter experts agreed to condense their presentations and get the band back together for a virtual presentation. In the name of education, I'm grateful that NASSCO allowed us to revive this presentation. Today, we have in excess of 800 registrations. Bravo to each of you. Thanks for being here. To recap, yesterday we opened with the asset owner, Drew Muirhead, City of Brentwood, Tennessee, followed by Jim Harris of Jacobs on condition assessment, followed again by the voice of a specifying engineer, Carol Giokas of RJM Group. Today, we will open with our utility contractor, followed by on-site inspector, returning once again back to our asset owner to compare life before and life after a comprehensive team effort on manhole rehab with the City of Brentwood, Tennessee. And before I introduce you to CK Masonry, the poll questions will continue in a manner similar to yesterday. This will be the 4th of 6 interactive questions. And the first question: which of the following, if any, have you experienced as reasons for manhole rehabilitation failure? Check all that apply. This is multiple choice. Wrong technology specified, equipment failure, inadequate surface preparation, no on-site inspection. Again, which of the following, if any, have you experienced as reasons for manhole rehabilitation failure? Hate to lead with a negative here, but it does lend itself nicely to our next presentation and content you can expect to hear from our utility contractor. Choices again: wrong technology specified, equipment failure, inadequate surface preparation, no on-site inspection. In a moment, we'll have answers. I'll be darned. I am gratified with this response because this is accurate. This is the most inadequate surface preparation is the single biggest reason for manhole failure. Thank you for acknowledging that and recognizing that. I appreciate your answers. Thank you. Wish I could serve up more than just 15 minutes of time with this gentleman by the name of Kurt Cohen, as he's a bright, driven man with lots of wisdom to share based on 23 years of experience in manhole rehab industry. So we'll just call this short presentation Distilled Wisdom. Please welcome Kurt Cohen from Nashville, Tennessee. Thank you for being here, Kurt.
Thank you, Don. And thank you for the opportunity to share my experiences in the manhole rehabilitation business. My name is Kurt Cohen. I'm the president of CK Masonry Company, Incorporated, based in Nashville, Tennessee. Today's presentation is entitled 13 Things I've Learned in 23 Years in the Manhole Rehabilitation Business. 13 things. Allow me to preface my remarks by stating that this presentation is not and ABCs of manhole rehabilitation, but a discussion of some of the nuances I have uncovered in the industry over the last 23 years. I hope at least some of the points will be of benefit to both collection system owners and design engineers alike. In basic terms, manhole rehabilitation is performed to achieve 1 to 3 things. Purpose number 1 is to seal the manhole from I&I, i.e. infiltration and inflow. 2 is to protect the manhole from acid attack. And 3, in very few cases, to build back structural integrity that is lost due to corrosion. All of the to be mentioned rehabilitation solutions provide an excellent seal from infiltration when applied correctly, but they do vary in performance based upon the acidity of the environment and the need for structural rebuild. With that in mind, let's discuss 13 points. First point that I would like to make is that it is useful to break down the types of solutions into 3 levels of chemical resistance. Level A products are Portland-based cement products. They provide an excellent seal and can provide structural benefits, but they only perform well in non-acidic environments with a pH above 3. Please understand that the pH scale ranges from 0 to 14. A pH of 7 is neutral, while lower pHs become more acidic and higher pHs become more basic. Our skin has a pH around 5.5, so we are actually a little acidic. Portland-based cements will disintegrate when exposed to pH environments of 3 or less. Therefore, if you have more moderate acid issues, a level B product may be best. Calcium aluminate cements perform down to acid levels ranging from a pH of 2 to a pH of 3 on the pH scale. Finally, if you have significant corrosion due to microbial-induced corrosion, MIC, or for other reasons, then a level C polymer resin-based solution would be best. These would include your epoxies, your polyureas, and your polyurethanes. They all perform down to a pH level of 1. My second point is that regarding calcium aluminate cements, please note that not all calcium aluminate cements are alike. There are 100% fused calcium aluminate cements where the cement and the aggregate are both calcium aluminate. And then there are calcium aluminate blends where the calcium aluminate is the cement, but the associated aggregates are less expensive materials. Performance-wise, the differences are 100% fused calcium aluminate performs down to a pH of 2, while the blended products perform down to a pH of around 3. If a design engineer does not specify, the contractor will choose the less expensive option, but the structure will not be as well protected in the more acidic environments. Point 3, when making a replace or rehabilitate decision regarding a manhole, we often think that it would be best if we could just replace the manhole. However, proper manhole rehabilitation can be superior to manhole replacement in many cases. Let's compare replacing the manhole with 4,000-pound Portland-based precast sections versus spraying the existing brick or concrete manhole substrate with 1 inch of engineered cement profiling material and then topping it with 250 mils, i.e. a 1/4 of an inch, of either a polyurethane or an epoxy. In the case of replacement, each precast section is designed to a depth of 530 feet. Conversely, the cement profiling plus 250 mils of epoxy or polyurethane can perform down to a depth of 275 feet, plus the added benefit of the underlying structure. The rehabilitated manhole will enjoy monolithic strength and cohesion, whereas the precast sections will suffer from weak points at each joint. The monolithic nature of the rehab manhole means that it will enjoy improved tensile characteristics and will not easily separate under hydraulic loading. I have seen precast cone sections separate at the barrel sections due to hydraulic uplift. This happened to manholes in a city in southeast Tennessee near the Tennessee River during a flood event. Furthermore, since the composite rehabilitation enjoys acid-resistant polymer resin coating, it will enjoy excellent protection against microbial-induced corrosion. Manhole rehabilitation can enjoy the benefits characteristic of no-dig technologies. There will be no collateral damage to streets, sidewalks, yards, or other utilities, not to mention reduced public inconvenience. So in many cases, the rehabilitated manhole will be lower in installation cost, plus enjoy the added benefits of being monolithic, acid resistant, and less disruptive to the environment. My next point I'd like to make is better sewer system containment is actually contributing to increased corrosion of concrete and brick manholes. As more basins are rehabbed to prevent stormwater infiltration, there is less dilution of the sewage. More systems are built with grinder pumps and lift stations that can cause splatter. More lids with holes in them are being replaced with solid lids, and in many places, specifications are calling out for watertight bolt-down lids. These factors result in fewer opportunities for the system to breathe and more opportunities for latent bacterial growth that are the precursors to microbial-induced corrosion. We see this anecdotally when we flip lids and see aggressive amounts of rust flaking off the bottom of casting lids. The point I'd like to make is more and more manholes will require level C polymer resin-based solutions in the future. Point number 5 is wet wells at pumping stations require acid protection. It is best to do that at initial installation versus doing it as a rehab project. As a rehab project, there are multiple issues. First, we see major amounts of corrosion, sometimes down to rebar and beyond. Bypass pumping is a must. Pressure cleaning of the corrosion can result in significant amounts of granular spoils that must be removed from the bottom of the structure. We have actually used vacuum trucks in the past to suck up all the spoils. Larger wet wells require the construction of scaffolding, and sometimes temporary flooring is required, which further increases cost and delays. Rehabbing a wet well can become a major investment in time, money, and engineering. It is best to acid protect a wet well at a pumping station during the installation phase. Point 6 is, there are those who want to seal the manhole down to the flow line, but avoid coating the invert. Why? Coating inverts with cements and/or polymer resins is expensive. Expensive quick-set cements are usually needed. Flow-through plugs and/or bypass pumping is needed in order for the materials to cure, and labor costs are significantly higher to coat the inverts. However, inverts need to be coated because they are a major source of infiltration. Secondarily, invert repair is fundamental to vacuum testing. No invert repair, no vacuum testing. Point 7, certain level C systems can coat the most remote manholes while others struggle to do so. Because of short pot life, all polyurethanes and polyureas and some epoxies must be applied using spray equipment, which can have limited reach. Certain epoxies can be mixed and applied by hand. When specifying acid protection for manholes with remote access, it is useful to consider the limitations of the delivery systems and specify products that can be delivered to the site. Point 8. On rare occasions, there is a need to structurally rebuild an acid-corroded manhole as well as protect it against future corrosion. In those instances, a level C product that has superior compressive strength is advised. In general, 100% polyurethanes and epoxy sprayed to 250 mils or more provide structural enhancement to the structure. Typically, layered foam products do not. If structural rebuild is desired, epoxies and 100% polyurethanes should be specified at a minimum of 250 mils, or a composite system, including the enhancement provided by engineered cement, should be employed. Point 9. If a wet well or a manhole has been recently installed, it is necessary for the structure to cure before protecting it with level C polymer resins. This is due to the heat of hydration and outgassing common to curing concrete. While the desire to complete the project quickly is important, it is necessary for long-term reliability to wait at least 28 days before applying the polymer resin. If not, delamination and bonding issues will ensue. Point 10. Regarding polyurethanes and epoxies, both options are excellent at providing seal and acid protection. In a head-to-head comparison, each has advantages. Polyurethanes cure much faster than epoxies, allowing for flow to be put back on the system sooner, particularly when coating inverts. Epoxies typically will present a better bond, are less expensive to moisture, or less sensitive to moisture, and many are available in buckets for coating hard-to-reach manholes. Point 11. Many collection system managers will give up on a manhole and recommend replacement because of significant infiltration issues. However, polyurethane grouts can be used to stop the worst types of leaks inside of manholes, including badly deteriorated mortar joints, major gushers and squirters, annular space boot failures, precast joint leaks, and hairline crack leaks. It is best to follow up the polyurethane grout injection with a structural coating of some type, such as a cementitious mortar. Point 12. Proper standardized testing on the seal of a manhole is important. The old exfiltration standard, where one seals the pipe penetrations, then fills the manhole up with water, provides a good confirmation of seal, but it is slow and expensive, and it does not give a qualitative confirmation of bond. The paint standard spark test is critically useful for level C rehab coatings to identify problem pinholes in thin coatings, but it does not confirm seal or bond. The gold standard for acceptance testing for a rehabilitated manhole is vacuum testing. It confirms seal and can provide a qualitative sense of bond strength. We recommend vacuum testing to the ASTM 1244 standard. And finally, we encourage collection system operators to dissuade public works departments from the use of metal grade rings during pavement resurfacing programs. Metal grade rings allow for major amounts of inflow into a collection system, particularly turnbuckle style grade rings. Usually they fit the frame of the manhole casting poorly. Some lids will flip out of the grade ring. Often vibration at the manhole caused by the ill-fitting grade ring will cause surface damage to the adjacent roadway. As a result, life cycle costs of metal grade rings are high. Better solutions are to make the final elevation and grade adjustments with properly installed brick and mortar or poured in place concrete. So there you have it. 13 things I have learned in the manhole rehabilitation business. Why 13 things? Because we don't have time for any more. Thank you for your time.
Kurt, you're spot on with that. Thank you. You're special. Thank you. Your energy and enthusiasm is appreciated. As usual, before I introduce our next expert on on-site inspection, now is the exact right time for poll question number 5. And I'll let that be presented and we'll review it together. And thank you for answering this together. This will be a true-false question, as I recall. Spark testing, thickness testing, adhesion testing is the responsibility of the inspector. True or false? I'll repeat. Spark testing, thickness testing, adhesion testing is the responsibility of the inspector. True or false? This is really not designed to be a trick question, but you might think it is when you see the answers here. Spark testing. So the answer is false, which is very accurate. The responsibility for spark testing, thickness testing, and adhesion testing is the responsibility of the contractor. The inspector is there to validate that. So good wisdom, group. Thank you very much. This character I've known for over a decade. I've asked him to be a guest speaker of some of the schools that I produce, and he's never, ever said no. He brings a style of teaching that's enlightening, which is why he's our PACP instructor at Madewell. Please know he's the voice, he's a voice on the NASSCO Technical Advisory Committee, and it's appreciated thanks to his 35 years of service to the Cincinnati, city of Cincinnati. As the instructor for NASSCO Inspector Training Certification Program, nobody better qualified to lead this next segment than Jerry Weimer. Thank you for being here, Jerry.
Thank you, Don. We're going to talk about manhole rehabilitation from the inspector's point of view. Okay, what does the inspector need to be doing while they are out there on site with the contractor? We're going to do an introduction and talk about the documents. We're going to talk about preparation, application and installation. We'll talk about testing and then acceptance. Okay. And then we're going to talk briefly about warranty inspections and a summary. As the inspector, you want to introduce yourself and give if you are certified or something, let them know that. So I would say, hi, I'm Jerry Weimer. I will be your ITCP certified inspector. That lets them know that I do have some training or some background in the inspection process, because too many times contractors show up and we have an inspector that has not been trained and they know very little about what's going on. So the contractor is constantly having to tell them what's going on, and the inspector has to rely on that contractor being honest. And then you want to talk to them, confirm that the products that are to be installed and applied are going to be properly tested in accordance with the contract's requirements. So we're going to go over the manufacturer specs and technical data sheets and stuff that's in the contract. What does the contract require? What products will they be using? We're going to check and make sure they have the right ones. We're going to look at the physical properties of those and the SDSs. What are the mixing procedures? We're going to go over those to make sure those are followed, and the application methods, because there's many different application methods depending upon the product. And what are the limitations of each product? Do they meet what we're trying to accomplish? And what is the preparation requirements for each of these? How do we need to prep? Because preparation is somewhere between 85 and 90% of your successful product. Okay. If the preparation is done correctly, you got a shot at getting a good manhole rehabilitation. If it is not prepped properly, no matter how good the product you're installing, it's not going to last. It will fail. And then we want to talk about safety protocols, PPE, personal protection equipment, and see the safety data sheets. We also want to talk about confined space, because we will, as inspectors, be going into these manholes, and we need to talk with them. Will they be providing the ability for me to go in, or will I be providing that ability by having someone come out and help me to go in and do my inspections that I need to do during the installation? So, will we be doing bypass pumping? That's going to be a very big question. Okay. And the other part of this is we're probably not doing manhole rehabilitation all in one day. Okay. We're going to prep it one day. Okay. We may install a product, but we may need to come back another day to do another product. So it may be over several different sessions that we're going to be at that manhole. So we need to talk about if we are bypass pumping, when. The safety protocols, like I said, the traffic control program. Okay, how are you doing safety, traffic control, confined space? Who is doing your confined space entry? Let me see the permit, so I make sure you have all the proper confined space entry permits because we will need to be going in at times. And a copy of all the safety data sheets for all the products you're going to be using. Those are required. We need those on hand in case something goes wrong. Preparation. What kind of preparation do we need? Do we need infiltration control? Do we have infiltration coming in that we need to stop? Will we be cleaning? Okay. What level of cleaning do we need to do? And do we need to alter the profile or do something else to make it compatible with the product that we're installing? These things are very important that we know up front what we're going to be doing. So if we have infiltration, how are we going to stop the water? Typically, we're going to use grout. Okay, chemical grout, but there's a lot of different types of grout. Okay, depending on the groundwater type, the soil type, things like that. So we need to use the right type of grout. So what type are we using? And what is our gel time? Because that can be very important. Are we doing a longer gel time or a shorter gel time to give it time to set and make sure that it does stop the leaks that we want to stop? How are we cleaning the surface of dirt and loose debris? Okay, so what equipment do you have? Are you have a pressure washer? At what pressure does it go? Do I need to use hot water for grease or detergents? And what are those that I'm going to be using in there? Okay, will I need to etch the surface once I'm done blasting? Okay, because we need to make sure all the loose debris, all the dirt is all removed. We need a nice, clean, solid surface before we can move on. And sometimes we do need to etch the surface. And what type of profile do we need on that surface for the product we're installing? So we got a couple of things here. We got moisture. Okay, different products adhere with different moisture things. Some need oven dry. Okay, no moisture whatsoever. Some air dry is okay. Some we can have a little bit of water there. And some they can be damp or wet. Okay, I need to know with the product what level of moisture I have. What profile is required? Okay, do I need a very smooth surface or do I need a rougher surface? Okay, what is the substrate that I'm trying to bond to? Okay, is that compatible with the material that I'm using? Because not all apply. We got to make sure that our substrate matches our product. The pH, is it within specifications of the product I'm installing? Again, pH is very important. And how are we testing that? And if it doesn't fall within specifications, what are we going to do to either bring it within specification or change to a different product? Like I said, the dryness level, we need to check that. And sometimes we do that using a vapor test. Okay. Or is there some other method we're going to use to test that dryness to make sure it does meet the specifications? The installation. Are we going to be spraying the coating? Are we going to be spinning it? Or are we doing trowel applications? Okay, very important that we know what we're doing up front. Make sure that we have the proper equipment and that it is operating properly before we start doing the coating. How thick of a coating do we need? According to the contracts. Okay, and when you measure it, I need to see the thickness gauge. I need to see the thickness. I want to check that. Okay, are you doing one coat or are you doing several coats? Okay, to get to that thickness. I do need to know that. We need to check to make sure we get the total thickness that we need. Okay, very, very important. And then we get to testing, the spark testing. Okay, like we said in the poll question, the contractor will do the testing, but the inspector needs to verify the testing. So we want to test the spark tester, if we're doing spark testing, against the rim, against the frame, make sure that it is actually working. There have been cases where someone spark tests it, and then when they check it, the wires going into the box aren't connected to anything. So we want to test it before we spark test the manhole. And then we circle all of the pinholes. Okay, and that's what we're looking for, pinholes going through. Okay, we're going to document that, and we're going to document the repairs. Okay, because if there's pinholes, there needs to be repair, typically with the same material. If we're doing cementitious, we have slump tests that we want to do. Is the concrete the right consistency? But we're also going to do compressive testing, either using a cube or a cylinder. Okay, and we're going to watch while the contractor fills these samples, packages them, and ships them off. We want to make sure that the samples that get sent off are the ones from this manhole. Okay, and we need to do this at each one. So we want to make sure the documentation is correct, and we track it and sign off on these things to make sure it's done correctly. Are we doing core testing? Okay, or ultrasonic? Okay, and when was the last time your equipment was tested? When was it calibrated? The pool test, we're going to pull samples off to check the adhesion of epoxies and polys, things like that. And we need to have the right size sample, and we need to check what is the pool strength that it takes off, and what are the repair techniques we're going to use to fix those samples. Are we doing ultrasonic testing for thickness? That's also important. But when we pull those coupons, I'm going to check the thickness there. That's another double check on the thickness of the material, make sure that it is the proper thickness. Okay, and I will be documenting the results of all of these, okay, as I go through. Okay, I'm going to absolutely test at least the first 2 manholes with the adhesion testing. And depending on how those results come off, I may end up testing every manhole, or I may just do them at random. Okay, depending on, are the results good? Is everything else going well? Okay, and I document those results. Okay, but I want to make sure that I am testing as needed to make sure that our products are installed properly and they're going to last. The bonding is good. Acceptance. Okay, this is a sample form that an inspector would be filling out. Okay, and this form is not only to protect the municipality, it's to protect the contractor. Everything that is done is checked. We have the material. Is it within spec? As specified, did it pass the inspection? And everything, any quantities, any comments we need to make. Okay, so that in the future, if something comes up, we have the documentation to say, yes, it was done properly, or no, it wasn't. Because sometimes we do everything right, and then a year later, something comes through, a slug of something, and it makes it fail. Well, we can go back to the record. Yeah, it was installed right, so let's see what happened that caused it to fail. If it was installed properly and everything was mixed, everything was done properly. Then we talk warranty inspections. Okay, it's very important that we do warranty inspections on time. Okay, and in the contract, it should say who is doing the inspection and what type of inspection is it going to be. Are we going to do a vacuum test? Are we going to do a pool test? Okay, or a spark test within that warranty period? And what are the agreed upon repair methods if it does fail? Okay, so just as a summary, the inspector is out there to protect the municipality, but also to protect the contractor with the documentation. Okay. And we're going to go through, we're going to check that preparation. And that typically does warrant going into that manhole to inspect it. Does the inspector have to go in every manhole? No, but they should go in at least the first one or two, and then periodically from there on, kind of at random, okay, to inspect the preparation of the manholes, make sure it's being done correctly, okay? The installation, making sure that it's installed properly. The first one is very important, usually the first one or two, because if they're doing those, they know you're keeping an eye on them. Then you can typically move back to checking more periodic, okay, more random. And then the testing, okay? Making sure the testing is done as needed, documented, and the samples are kept, okay? We need to keep those samples as warranty pieces until that warranty expires to make sure that everything is there and we have the documentation, both the physical evidence as well as the written evidence, okay? And then do the warranty inspections as needed on time, because if we let the warranty expire and something happens, then it's all on us, okay? So we need to make sure of that. So thank you. And I'll move it on to Don.
Good summary, Jerry, and well stated. So what happens when you hear the stories of 5 experts who understand the meaning of team relative to manhole rehab? You go back to the beginning. But once again, it's time for our 6th and final poll question, and I'm betting everyone will get this one right. So here's the question. What's the most important task to turn chaos into calm as a municipal asset owner? Get your asset inventory as accurate as possible. Condition assessment is completed for planning and budgeting. Make sure the specification is clear and concise. Hire a competent utility contractor. On-site inspection is confirmed. All the above. I'll repeat the question. What's the most important task to turn chaos into calm as a municipal asset owner? In a moment, we're going to bring up our municipal asset owner and let him finalize his thoughts. And the answer is, oh my gosh, all the above. So there really isn't a right, wrong answer to this question, but I really like how you've leaned toward all the above and grasping the idea that to do manhole rehab justice, it takes a team effort. Thank you. Maybe at this point, Drew Muirhead does not need an introduction as our asset owner, but I'll encourage his thoughts on life before and life after a comprehensive rehab program, including mainline pipe and manholes and laterals, and how he benefits today from a team effort not so long ago. Welcome back, Drew Muirhead.
All right, thanks, Don, for the introduction. Just to kind of recap, I'm with the city of Brentwood, Tennessee, with the water department, and have been overseeing the sewer rehab program and manhole rehabilitation. While working here with the city, I offer a different perspective in that before coming to the city, I actually worked as a consultant with the city at the initial start of their program back in the mid-2000s. So today I'll be wrapping up our 2-day webinar and going to look to provide you with the owner's perspective, kind of at the end of a successful rehab project, manhole rehabilitation work that's gone on. I'll be using, again, the city of Brentwood and our efforts since the mid-2000s to today and in the future as far as our rehab work. And in particular, for this presentation, the manhole rehabilitation. And so to kind of go back and recap from the first presentation yesterday, a quick timeline of as the owner and what we've had to deal with to kind of get us to the point where we're actually doing manhole rehabilitation. And for the city of Brentwood, we obviously had issues with our I&I and our SSO, sanitary sewer overflows. And so in 2006, we entered into agreed order and you know, in order to force us, I guess, to get into our rehab program. In 2007, we came up working with engineers with a corrective action plan engineering report that outlined our program for future years. In 2008, we actually began our actual rehab work in manhole rehabilitation. And then in 2015, we kind of reassessed our program and realized that additional work was required and extended that program for another 5 years. And then in 2019, we kind of took a pause in another study and looked at our work and came up with a post-CAP-ER rehabilitation program with our TDEC regulatory agency and are continuing to do rehab work to date. And so to kind of go back in each of the different phases through our program since 2008 through 15, we ended up doing about 20% of our system rehabilitated. And again, the approach we took was we wanted to get in an area and do every aspect of the sewer infrastructure. So we would rehab the line, the laterals, and the manholes on either side of that pipe segment. And the idea being that not only will we prevent or stop any current leaks or defects, but also maybe be a little proactive in preventing future issues that may occur to that aging infrastructure. So in those early years was a big portion of our rehab, and we had about 25 miles of CIPP of our clay and concrete system. And then kind of as it relates to this presentation, we ended up doing about 1,200 manholes during that phase. I want to take a moment and kind of tell a little story. I think this story fits well with the presentation and our team aspect and the presenters that have come before me here today and yesterday. In 2013, the end of 2013, we using our flow monitoring analysis and our hydraulic model that I mentioned in yesterday's presentation, we identified that there was an increase in our average daily flow. And so we ended up inserting some additional flow meters, doing some additional I&I analysis, and had kind of narrowed a portion of our trunk line that runs through a large farm pasture area, one of the last remaining areas here in Brentwood. And this trunk line section runs along the Little Harpeth River that runs through Brentwood. And so we got to looking at that, and the branch segments that tie in and the flow that we were seeing just didn't add up. And so kind of left us scratching our head. And a year prior to this, we actually rehabbed the 24-inch clay pipe through this area also. And so we felt it was time to do our manhole rehabilitation for this portion. So we brought in our rehab contractor and began manhole inspections and began to do the rehab work. But during that process, we didn't come across anything significant that would amount to the flows we were seeing through that area. And so as our manhole rehab contractor began his work, they were actually prepping one particular manhole. You can see it here on the photo there on the right side. The castings are on the bottom of the photo, and the river there is just a few feet away from the bank. And they were prepping this manhole, and actually the guy stepped off into a hole down in the trough of that manhole. During flow conditions, you couldn't see the hole, obviously, and you couldn't tell anything different. But we began to notice that the river was actually flowing into the bank of the creek side there. And we did a dye test, and there you can see the results of it there on the left photo, the pink dye. We actually put dye tablets right there on the edge of the bank, and the dye within 30 seconds was entering the bottom of the manhole in the trough. Again, you couldn't really tell it was a three-way manhole, 90-degree, 24-inch pipe. So the flows were significant enough that you couldn't see the incoming flow. But when you did the dye test, it was a substantial amount of flow of basically river water coming into that manhole. So we worked with our contractor and our engineer to come up with the solution. We looked at options of replacing the manhole, but due to the proximity of the river, and just general costs, we thought it was maybe a little easier, quicker, and cost effective to attempt to rehab this. And so that's the process we decided to do. And the only problem was when we went to go rehab, we're going to do grout injection. We went to rehab this manhole, and the grout injection, the flow coming into that was so significant that we couldn't, we just couldn't get the grout to set up in that hole. And keep in mind, we were bypassing at this time. And so, but again, the amount of water coming in was just pretty significant, and we couldn't get the grout or anything to set up in that hole. And so eventually we spent some time that day while we were on site with our engineers and the contractor and our inspectors, and came up with a solution that we would actually plug the downstream line and fill the manhole up with the river water to equalize the pressure head between the river and the manhole. And in doing so, we were able to get some sandbags on top of the hole. Our contractor was able to get in, do some grout injection, both through the manhole walls and outside, to where we were able to slow and almost stop the inflow coming in that manhole. And then ultimately, we were able to release the plug, release that water downstream, continue our bypass pumping, and the contractor was able to get in and do a complete and full rehab, both in the trough and all the way up to the casting of that manhole. Something to note, the pre and post flow monitoring data that we collected from that period of time, we estimated that there was about 750,000 gallons a day coming through that hole in the bottom of that manhole. It's about a 4 to 6 inch hole in the bottom of that manhole trough. So anyway, that's a pretty significant leak, and again, kind of ties everything we're talking about together. That from our perspective, working with our engineers, utilizing flow monitoring data, hydraulic modeling, and then actually our inspectors, our engineers, looking at options, and then our contractor to complete and fix a problem. So to continue on kind of throughout our years of rehab here in 15 and 18 was kind of another phase. Again, we did about 6 miles. We kept with our same process of going into an area and doing everything from the main lines, laterals, and manholes. And again, at this phase, we did about 400 manhole rehab. And again, just to note, our manhole rehab process was we use a cementitious coating followed by an epoxy top coat. So now, as an owner, one of the big things that we're interested in, mostly from either a regulatory standpoint or our city managers or commissioners, is you're spending all this money, you're doing all this manhole rehab work, you're causing neighbors and residents to be angry at you. What's the benefit? What are you getting out of all this? And so I'm going to kind of quickly go through a couple slides to show you some of our results to our program. And so this first slide shows our annual overflow events and rainfall. You can see there in 2007, just before we began our actual rehabilitation efforts, we had about 16 and then 18 there in 2008 overflow events. And you can see our rainfall was kind of steadily increasing. And then after that, from 2008 to 2010, which we did a good majority of our manhole rehab and other rehab efforts, you can see our overflow events going down. However, our rainfall totals stayed around 45 to 50 inches a year. And you can see our efforts kind of continued and stayed level. Another thing to note there in 18 and 19 and 20, You can kind of see while our rainfall did increase, our overflow events increased. And that is kind of some of the reason why we've continued and stuck with our rehab efforts and continuing to utilize manhole rehabilitation as part of those efforts. Just another quick snapshot, I guess, of our work and kind of our results. Again, in 2008, when we began our rehab program, you can see there the annual rainfall in 2020 went from 46 to 59. So, an increase in annual rainfall, 28%. Number of overflow events went from 18 down to 7, a 61% decrease. And what's interesting, and again, these are just estimations, but it kind of gives you a big picture idea. But our total overflow duration in hours went from about 1,800 hours there in 2008 when we kind of started collecting that data down to 186 hours in 2020. And so some more results, pre and post rehab analysis from 08 to 19. This is annual I&I that was calculated. And so our engineers have estimated about 1.2 million gallons annually we've removed through our rehab efforts. And keep in mind too, we don't have a treatment plant, so everything that we collect, we have to pump out, and so we pay basically a per gallon rate to have our sewer treated. So again, that's a direct savings on our annual budgets in those rehab efforts. I'll talk just real briefly on kind of our city growth. Two things out of this slide here. One, obviously, there's a 15% increase in city growth and population, and the reason we were able to achieve that was through our rehab efforts and our flow monitoring analysis and being able to document our efforts with flow reductions. And we were able to go to our TDEC regulatory agency and show them that the work we're doing, the time and money we're spending, but also the benefit of that effort. And so that we were able to get a moratorium relief from new connections and able to have I guess a controlled and monitored growth with our city. Again, just another a brief slide on growth and how our housing permits have went up over the years, and here recently they've kind of started to decline, but still there's been a gradual increase in growth here in Brentwood. And so I say all that about our growth, and while it hadn't been huge growth, but there still has been a positive growth. But our average daily flows have gone down during that same time period. We've actually seen a decrease of almost 1 million gallons a day in our average daily flow throughout a year. And so again, that can be completely attributed to our rehab efforts and particularly our manhole rehab efforts that we've put forth over the last almost 15 years now. So kind of where does that leave us today? Again, we are continuing on with our rehab efforts. 2019 through 2027 is currently what we've outlined and have put some parameters and requirements in for us. We're continuing on with CCTV. We've established 200 manhole inspections annually, kind of as our minimum goal. And we've also begun to implement other methods of testing for I&I, including smoke testing. I put this slide in here, but it, may not be the greatest thing to talk about in a rehab presentation, but I feel as the owner, it's good to provide the information and kind of be transparent and kind of the things that we've learned over the years. Our CAP-ER and our initial program has always kind of outlined an EQ basin, and we actually installed one, and it's online now as of December of 2022. It's a 4 million gallon, and so While that's beneficial, I also want to make note that we've obviously continued on with our rehabilitation program. I feel you can't have one without the other. If we would not have done the manhole rehab work over the last 15 years and other rehab efforts, the size of this tank, the number of these tanks would definitely have been a lot more than what we ended up doing here. And again, our infrastructure, manhole infrastructure continually ages. It doesn't get any better. And so it's an ongoing process, and working with our local regulatory agencies, we've determined that even though we're utilizing the EQ basin, we're going to continue on with sewer rehab, as we feel for our situation, rehab's been effective and we've achieved a lot over the years. So again, just kind of in summary, life is good and finally in control. And so I've kind of walked you through as an owner at the beginning. You know, it ain't easy being me at the beginning. It's very difficult, regulatory, financials, trying to put together the team as we discussed through all these other presentations, and working with different skill sets and different disciplines to put together a manhole rehab program, project, products being used that works for your local city and community, and stuff that we have found beneficial and ultimately has resulted in great results for us, and looking to continue that work for the future here in Brentwood. And with that done, I'll turn it back to you.
Drew, we really appreciate the factual storytelling and of your experience there. You opened it and you closed it with a good benefit case. Ideally, other municipal stakeholders will be encouraged to fight the good fight, to control I&I, to mitigate SSOs, and to enhance the life cycle of their underground assets. Those are the numbers that are worthy of posting on a scoreboard so the entire team can celebrate victory. And with that, I'm going to turn this presentation over to Sheila Joy, who's been serving as the executive producer behind the scenes. Sheila, can you join us?
Here I am, Don. Thank you. Just wanted to kind of close out, have a few final words to, first and foremost, thank all of you for participating. We had a really high level of interest in this, so clearly it's a subject that many people are interested in. But more specifically, I want to thank our panelists. The folks that took the time to be here are volunteers. They were not compensated for this. They just really have a unique passion and a desire to share what they know with all of you. And it was really a great panel because we had everything from consulting engineers, public agencies, suppliers, those who've worked as contractors. So you really got the full picture from these folks. And I feel that this webinar is going to be something that many of us will go back to in the years to come as a resource. I want to specifically thank Carol and Don. They've both served as chairs of our sewer structure rehab committee. This is a photo taken at our annual conference back in April. But this committee works extremely hard, not just for manholes, but for all sewer structure, to help educate on assessment, maintenance, and rehabilitation. So thank you to that committee for all that they do. I also want to share that if you're not a NASSCO member, I would love for you to join us. But whether you are or not, we have many, many resources available to the industry. One that you're probably familiar with would be our Manhole Assessment Certification Program, which is part of PACP as a prerequisite, but that is another course that is available. And of course, Jerry talked a lot about the Inspector Training Certification Program for manhole rehabilitation. And you can learn more about those programs and many others at the NASSCOtrainingsource.org. We also have many specification guidelines for all types of technologies. It just so happens that the committee is currently working on an update to the manhole rehab performance spec, and that will be coming later this year. All of these resources are free and available for download at NASSCO.org. NASSCO also partnered with ASCE on the Manual of Practice MOP 92 Manhole Inspection and Rehab Manual. And that came out, I think, a couple of years ago. very hard work by the NASSCO at that time Manhole Committee. So I want to thank them for that. But that's another resource available to you. And then we also produced a great video, Manhole Rehab video. It is on our website. It's also on our Vimeo site. It is something you could actually download if you'd like off of Vimeo and use on your website, perhaps. But we encourage you to watch that. It's a short video, but it gives the whole picture on all of the different technologies available for manhole rehab. And then this committee also worked with WEF, the Water Environment Federation, on a sanitary manhole rehab fact sheet. So that is another resource. Again, many, many things available to you on NASSCO.org. We invite and encourage you to take advantage of that. So in closing, I just want to remind you that this webinar has been recorded. It will be on our website probably within the next week if you'd like to share it or watch it again. For those of you who attended both days and will be getting CEU or PDH credits, you don't need to do anything. We will track attendance, and then you will probably get something, I would say, within the next 2 to 3 weeks. You will get those directly. Also, Don mentioned this, but you'll be getting an email from SurveyMonkey later today. Please, that is the opportunity for you to ask any and all questions you might have. Again, our response to this was so high. Currently, we have 368 people online, and that's even dropped off from what we had before. So we need to thoughtfully answer all of your questions. And if you complete that survey, you'll have that opportunity. So in closing, thank you, thank you. I hope you learned a lot. I know I did. And we hope to see you at the next NASSCO webinar. Take care.